we're nearly at the finish line in terms of our audio file. So with it being mixed and edited, let's now get it shipshape for podcast uploading. So as we've already covered, properly produced podcast episodes are recorded to some sort of storage. They are mixed so everyone's voices are level. They are edited to remove the boring bits or the mistakes, and they are exported as a 64 kilobit per second mono or a 128 kilobits per second stereo MP3 file. Goodness me. What's all of that mean? Well, let's start with mono. So the human voice is mono, meaning that it only comes out of one channel. The human voice, like any instrument really, any smaller instrument, certain larger instruments like a piano, you might hear the low notes and the high notes in different ears because a piano is big, right? And yeah, the human voice, on the other hand, it's one source of sound, and so we can consider that when we think about whether we need to make a stereo or a mono MP3 file, because most podcast episodes are just people talking, and the voice is mono. Now, not everyone hears equally in both ears. There could be a variety of different reasons, either something that a person is born with or just hearing loss over time. And we're not necessarily talking about people at a specific age. It can happen at any point for any reason. And just naturally, people have good ears and bad ears. And so we want to think about that when we're considering whether we make stereo files. Also consider when people are driving. If you're taking a long road trip and you make a stereo audio file and you're in the passenger seat and there's a driver, each one of you, depending on how the stereo file has been made, one of you is going to hear one section of the conversation better than another person, because the left channel speaker is on the left doorwell in the car. The right speaker channel is on the right doorwell in the car, depending on whether you drive, which side of the road you drive on. That's either the passenger's side or the driver's side, right? But that means then there's an imbalance created there, because not everyone is going to hear the conversation equally if a voice is really panned to the left or the right. People sleep with one earbud in. They take their podcasts to bed with them, and they might listen with just one earbud in, because obviously two of them would be uncomfortable. And so, again, if you're extremely panning sound, important voice stuff left or right, then some or all of that is going to get lost because one of the earbud is, on the bed or whatever. So that's mono, and a little bit of stereo. But let's dive a little bit deeper into stereo. So it is effectively two mono files. A stereo MP3 file is two mono files squished together, a left and a right. That means it's twice the file size, which also means twice the bandwidth, both for you as the provider, but also as the person downloading that audio. And then that obviously means it's twice the time that it takes to download that audio. There isn't an appreciable change or improvement in gain by making our conversations stereo. There really isn't. One of the little ancillary benefits is that if you have two people that sound similar, then you can pan them subtly to the left and the right, but I still wouldn't. You're still making that file twice the size, and there's probably other ways that you can assist people in telling the difference between two speakers. In drama and in narrative shows, it's really common to produce in stereo, and I've done the same. But again, the sound effects and the music might be in stereo, but the voices, everyone speaking, they're still right slap bang in the middle center channel, if you like. So they are effectively mono. We're not biasing one side of one ear or the other. So it is useful for music-heavy podcasts, which we're probably not going to be making. We've already discussed how we kind of want to use music that is distinctive, but use it sparingly. If you've got stories with immersive sound design, this typically is fiction, but sometimes narrative content can benefit from that. You can create a sort of quite a dramatic and interesting environment by using stereo. And like I said, you can use it to tell a couple of similar voices apart if you need to. So next up then, let's look at bitrate. So I talked about kilobits per second. Bitrate is the amount of data that is stored per second, and it's measured in kilobits. A 64 kilobit per second mono file is the standard that we go for, and that is literally half of 128 kilobit per second stereo file. 64 is around the minimum I would recommend as a bitrate for the human voice. Anything lower than that, and it starts to sound because you will notice it at 64, especially if you have someone who's very sibilant, where the S's have a bit more of a hiss to them. You will notice that more with a more compressed 64 kilobit per second file. But again, unless it really matters to you, that particular crystal clear sound, I wouldn't worry too much about it, and you can save yourselves money. And if we think about podcasting in emerging markets in India and Africa, where frankly just internet stuff is more expensive and people don't have quite so much of it, then we can really do our listeners a great favor by literally halving the necessary file size. Now, music doesn't sound great at that 64 kilobit per second mono file, but again, because we're using it sparingly, it's not too much of a problem. Now, there's this idea of constant bitrate versus variable bitrate. This is something you'll come across when you're exporting audio in various applications, be it Descript or Audacity or other applications. You may be asked when you export out as an MP3 file whether you want to make a constant bitrate file or a variable one. Now, a variable bitrate means, as you might guess, that the bitrate can go up or down depending on the complexity of the sound that needs to be represented. So again, if we think of something that's quite complex, or where there's a lot of those higher frequencies that are usually the ones that get compressed down, or low, very, very low frequencies that usually get compressed out as well. And again, now with compression, I'm talking about file compression. That's one of the reasons that we're able to reduce file sizes, by taking those really high bits and those really low bits and sort of cutting out bits that we probably aren't going to hear. A variable bitrate file will do that multiple times within the audio based on the needs of that particular piece of audio. The problem that creates is it makes it difficult to predict where certain things happen in a file. For example, with a constant bitrate, we know that we know how to find the 3-minute mark. If you've split your episode up into chapters or whatever, or it's a long file and you need to sort of seek through it, scrub through it using an episode player, it's harder for the technology to do that if the file size keeps changing for certain bits. If that doesn't make sense, then don't worry too much about it. All that's useful to know for you is when presented with the option, go for constant. There's no appreciable benefit, and there are significant drawbacks to using variable bitrate. So whenever asked, always go constant. Next up, we're going to get a little bit more technical and look at sample rate. And this is just so that this is really just so you know kind of situation. So I like to imagine audio. I mean, it's not something I do a lot, but when I do, I imagine analog audio as a river, right? So think of a river or a stream, and we're going to test the water in that stream every hour in a test tube. So we're going to dip our test tube in, and we're going to see, check like the pH balance or whatever of that water. The more we test, the more accurate the data that we get about the pH balance of that water. Digital audio recording works in the same way. We are dipping our test tube into the ether where those sound waves are being transmitted. It's oversimplifying, but it's exactly the same principle. We are taking our test tube and we're dipping it into the wave, into the water, in exactly the same way, so that rather than testing, we're getting a sample of the various frequencies and we're capturing that. But we're doing it very, very many times a second. So rather than once an hour, we are doing it 44,100 times per second. That is a lot of dipping. It's a lot of test tubes, but that's what we do. And we measure that in kilohertz. So it's a cycles per second measurement, which is measured. It's actually measured in hertz, but we use kilohertz. So that would be 44.1 kilohertz or 44,100 hertz. And hertz just means times per second. The reason we have that number is that around 20,000 hertz is the limit of human hearing. It's the topmost frequency that the average human can hear. And so anything above that, we're not looking to sample that. And so we're doing twice that. And we do that. We're going twice the limit of human hearing because of maths and to do with how waveforms work and being able to capture data at the top of a waveform and at the bottom. If you think about vibration, all sound is a vibration, and so it's like a wobble, right? So if you think of a jelly wobbling, it wobbles from left to right. In waveforms, we think about it visually as wobbling from top to bottom. And in order to accurately represent audio, we need to take the top of the curve, the top of the wobble, and the bottom of the curve, the bottom of the wobble. And so we need to be able to do that 44,000 times. The reason we tack the extra 100, or the reason that we, instead of going for like 40,000, we go for 44,100 is boring and unenlightening. It's to do with weird technical standards and stuff. But now you know. Now let's look at loudness. So we've talked about limiting and compression, audio compression and dynamic audio and all that kind of stuff. Let's have a little chat about loudness. So all episodes of your podcast should be equally loud so that people aren't having to constantly change their volume between episodes of your show or episodes of other shows as well, all being played together. We also want to think about it should be mixed so that when you listen to an episode, if your phone then goes bing with like an email notification or, that little pop-a-dom sound that an iPhone makes, it shouldn't be so loud. You shouldn't have had to have turned your phone up to hear the podcast and then suddenly that ping notification is blowing your eardrums off. We want to make sure that the audio is fairly equally loud to that notification, that interruption sound. And we measure that loudness in LUFS, which describes the loudness over time. It's a perceptive measurement, and it stands for loudness units relative to full scale. Yeah. And it's an average over a given period, not sort of right now. So if we think about a decibel measurement, that's a signal measurement. That's saying how much electrical signal is going through right at this millisecond, whereas loudness is a perception over time, and it's much more human. It's a much more human measurement of how loud does this sound, not how much electrical signal is actually going through this piece of audio equipment, because who knows, right? So we use LUFS as a measurement of perceived loudness over time. LUFS averages out the loud and the quiet parts. It doesn't do anything. It's a measurement of that then takes an average of the loud and the quiet parts. And then we use audio editing apps to output the audio at a specific LUFS level. We can also use metering within our application. So there are apps that have options where you can pop up a little meter. And there are all sorts of different types of meters for measuring signal strength and volume and frequencies and all sorts of stuff. But you can also add a LUFS meter, and that will show you in numerical form, but also in graphical form as well, as you start to play the episode through, what is the average? And you will see the average even out over time. So it will start sort of varying wildly because it's only got, a few seconds to deal with to get an average from. As you start to listen to the rest of the episode, that average will even out because maths. So the industry standard that we go for with LUFS is minus 16. That's just the number that we've standardized on. There is a bit of a range that we can go for. Apple says it's okay if it's like minus 15 or minus 14, either way, or minus 17, I should say. So anything in the sort of range of 14, 15, 16 is okay. 14, 15, 16, 17, you get it. That's fine. And when we're talking about this, no one's going to reject your audio. No one's analyzing the audio to say this is too loud or too quiet. But hopefully that is something that you will do yourself, or just make sure once you've got compression applied to your audio, if you are using multi-channel audio, then you might do compression multiple times, because you might compress each person's track, and then you might take compression and limiting and apply it to your whole file. Once you've done that, you're sort of fairly safe and you're consistent in your volume levels, which is great. Then when you come to export your audio file, you can say, I want this exported out at a loudness level of minus 16 decibels or minus 16 LUFS, and that will keep your audio to that industry standard. So exporting it out for podcast players, like I said, DAWs work in multi-file projects. So if we talked about those swimming lanes before, where you're dragging in audio and you see them as vertical tracks. A DAW works when you actually hit save. You're not saving an MP3 file of the finished audio. You're saving a project that you're going to work in. So once you finish doing the work, you need to export that audio out as a single file. You can't take like an Audacity project and upload it to your media host, because that's not an MP3 file. It's basically a set of instructions for what to do with audio. So once you're finished and you've done all your mixing, you've done your compression and your limiting and your all that stuff, then you can, in your DAW, your digital audio workstation, you can say, I want to export this out to a single file. MP3 is the most popular format that we use. So we've talked about bitrate and all that kind of stuff. That's all part of the MP3 standard. And we just all agreed that MP3 is the version we're going to use. You've already seen in the Twisted Wave thing that we did in the previous lesson, there's lots of different audio formats. We don't care. We're not fussed about them. They're for other people. MP3 is what we use. And the settings that we want to apply, if you remember our sample rate discussion, 44,100 hertz is the sample rate that we want to export out. We want to export out a mono file in most cases and set a constant bit rate of 64 kilobits a second. And then, given the option in our software, we want to export out at minus 16 LUFS. Homework time then. So, if you upload your edited trailer to this loudness.info website that's also linked down below, that will give you a measurement of your loudness level for your whole trailer that you recorded. This will be the one that you've now edited in Twisted Wave. Then I want you to head over to Cloud Convert and convert that to an MP3 file. Apply any volume boost if needed. So if, for example, you find that your loudness level is, let's say, minus 32 decibels, then maybe that's way too quiet. So you need to apply 200% volume limiting, or volume boost, if my maths is accurate. Have a play with that and see what happens. So give that a go. And then once you have done that, you've got your finished converted MP3 file. We will meet back here, and then we'll actually upload that bad boy.